Right. Last week we spoke about properties of materials. We spoke about the strength of materials, boiling point, melting point, as well as flexibility. Now, today we are going to look at electrical conductivity. Now, what is it to need to know with regards to electrical conductivity? Here I have a diagram that illustrates the electrical circuit, and it consists of your battery, your switch, and your bulb. Now, according to this picture, you will see the switch has been turned on, and therefore the bulb will light up. Now, if I open this switch, turn it off, I would then cut the circuit, which means electricity will not be able to flow through the circuit. So the circuit at this stage is complete. It flows through from the negative right through the circuit to the positive of the battery. But the moment I switch off or turn off the switch, you will notice that there will be a cut in electricity. So if I look at the wire, the switch is actually called a conductor. It conducts electricity from the white wire to the red wire. Okay, so we call this metal piece also a conductor. What do you think what's going to happen if I connect this wire with that wire by means of not metal, but I use plastic? It won't work. Wood, it also will not work. Then the insulator would then be the wood that I referred to, or the plastic that I referred to. Now, we must now know, if I look at this particular tool that we have here, it's our cutters. You will notice that it has a conductor in it as well as insulator. So for instance, if I now have to cut a live wire, and this is not on my cutters, these plastic handles, then I'm obviously going to be in for a big surprise. I'll have electrical shock, because electricity flows through metal, as I've just shown to you over there. This is metal, that's more like a plastic. So my metal part would be then my conductor, and in the event that I do not want to shock, I would then the handle will be covered with plastic, and that will be called an insulator. So now what we learn from this is metal is a good conductor of electricity, and insulator is a poor conductor. In fact, it doesn't allow electricity to flow through that particular material. Right, now let's look at heat conductivity. Now, heat conductivity is to do with something that's getting warm, that you can't touch, for instance. Remember, there's a difference with electricity that will shock you, but heat refers to that you won't be able to touch at all in certain cases. Now, we have the concept of poor heat conductivity and good heat conductivity. Now, let's see where would we find these two concepts. Now, this is a pot that your mother used in the kitchen. Now, some parts of it is plastic and some parts of it is metal. Which one do you think is a good heat conductivity part? It's the in fact, it's a poor heat conductivity is the plastic handles, because the plastic handles won't let heat go through. Therefore, they would construct and build these pots with plastic, or sometimes with wooden handles. And then obviously the metal part that allows the heat from the fire or the stove at the bottom to go through the pot, and that is a good heat conductivity. Now let's try this with a little bit of experiment. We have our wooden spoon, we have a plastic spoon, and we have a metal spoon. What do you think what's going to happen if I put all three of these spoons into a glass of hot water? And which of those three spoons do you think it will be not hot at all, and I will be able to take out the wooden spoon, because the wood does not allow heat to pass through it. So wood would be a very poor heat conductivity type of material. Plastic, the same thing, but metal, that metal, it is actually a good heat conductivity. Try that experiment at home, and I'm sure you will agree with me. Right, so I'm looking forward to our next lesson, and that will happen hopefully next week or tomorrow, and that is with regards to separating mixtures. Thank you and good day.